In this episode, we shift from thinking about tiny one-liners and short shell scripts to a different kind of scripting comfort that many Linux administrators eventually want, using Python to glue tasks together in a clearer, more organized way. Python is popular in Linux environments because it is readable. It has a huge ecosystem of reusable code, and it fits well when a task grows beyond a few lines of shell logic. At the same time, beginners often get frustrated because Python introduces ideas that feel like ceremony, such as virtual environments, dependencies, and modules. None of that is meant to slow you down. It is meant to keep your work stable as it grows. By the end, you should understand why small Python habits prevent big operational headaches, and why clean structure matters when your scripts end up being run repeatedly, shared with teammates, or used during an incident. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A helpful starting point is to recognize the difference between writing a quick script and building a tiny software tool. In admin work, you often begin with a simple goal like parse a log, check a configuration file, or gather system facts, and it is tempting to keep adding little bits until the script becomes complicated. Python pushes you toward structure, even when you do not think you need it yet, because it has strong conventions about where code lives and how it is reused. That structure is not about being fancy. It is about reducing surprises. When a script is readable, you can safely revisit it months later and still trust what it does. When a script is organized, you can test pieces of it and change one part without breaking everything else. This mindset matters for security too, because clarity reduces mistakes, and mistakes in automation often become outages or data exposure. One of the first admin-relevant concepts is the idea of the Python interpreter itself, which is the program that reads Python code and executes it. On a Linux system, there may be more than one version installed, and different tools might rely on a specific one. That can create confusion when a script works on one machine but not another, even though the code looks identical. The underlying issue is that Python is not just one thing called Python. It is a family of versions and installations, each with its own libraries available. When you hear someone say a module is missing, it often means the code is being executed by an interpreter that does not have that module installed. This is where a beginner can start thinking like an operator. The environment a script runs in is part of the script, even if it is not written in the file. This leads naturally to the concept of a virtual environment, which is an isolated Python setup that lives alongside the system installation. The common term you will see is virtual environment, venv, and the simplest way to understand it is as a private workspace for one project's Python packages. Instead of installing extra libraries into the system Python where they might affect other tools, you install them into the project's venv, and only that project sees them by default. This is important for admins because system Python is often treated as part of the operating system's plumbing, and changing it casually can break vendor tools, monitoring agents, or OS utilities. A venv gives you a safety boundary. You can experiment, add what you need, and remove it later without leaving the machine in a mysterious state. That boundary also makes troubleshooting easier because you can say, this script uses this environment with these packages, and it behaves the same every time. Dependencies are the next piece, and the word sounds intimidating until you connect it to something you already know. A dependency is simply code your code relies on, usually written by someone else, packaged so you can reuse it. In shell scripting, dependencies are often external commands, and you assume they exist because they ship with the OS or are installed by a package manager. In Python, dependencies are often libraries, and you need a way to ensure the right versions are available. This matters because libraries change over time, and a script written today might break in a year if it silently starts using a newer library version with different behavior. When admins talk about pinning versions, they're talking about making the environment predictable so a known good script stays known good. From a security perspective, dependencies also introduce supply chain considerations because you are bringing in third-party code, and you want a process that makes that visible and manageable rather than accidental. A practical way to think about dependency management is to separate three questions. What does my code need? Where will it get it? And how will I prove it is consistent across machines? Even if you are not building a product, you still care about reproducibility because admin scripts tend to spread. You run them on a laptop, then a test server, then a production server, and each hop is a chance for a mismatch. When a script fails only on one machine, a very common root cause is that the environment differs, not that your logic is wrong. Venv helps by letting you keep the environment close to the project, but you also need the habit of describing what dependencies are required. That description is part of operational hygiene, like writing down firewall rules or documenting a service port, because without it the next person is stuck guessing what to install. Modules are another concept that sounds abstract but becomes simple when you connect it to organization. A module is a unit of Python code that can be imported and reused, usually represented by a file or a package directory. Instead of writing one huge script with everything mixed together, you can separate concerns, such as parsing input, doing calculations, and producing output. That separation helps beginners avoid spaghetti logic where one change breaks everything. It also supports safer testing because you can focus on one module at a time. For admin work, modules are especially useful when you find yourself repeating the same patterns, like reading configuration formats, normalizing data, or validating input. Rather than copy and paste the same block into 5 scripts, you put it into a module and import it where needed. Over time, that turns your personal admin toolkit into something consistent and reliable, not a pile of almost the same scripts. It is worth noticing how modules change the way you think about code reuse compared to shell habits. In shell scripting, reuse often comes from piping text between commands or writing functions inside one script. Python reuse often comes from importing a module, which encourages you to name things clearly, keep side effects small, and treat your code like a library rather than a one-off. This is a big cultural shift, but it pays off quickly when you debug. If a module is written so that it defines functions and classes without doing work immediately, then importing it is safe, and you can call what you need intentionally. If a script does a lot of work at import time, it becomes harder to reason about and easier to break accidentally. So a gentle beginner goal is to learn to separate definition from execution, define reusable pieces and modules, and then have a small, clear entry point where the script actually runs. That simple separation tends to produce calmer, more predictable admin automation. Now let's talk about data types, because Python's core strength is that it helps you model information in ways that are clearer than raw text. In shell scripting, many values are strings, and you spend time splitting, joining, and pattern matching to get meaning out of them. Python gives you structured data types like integers, strings, lists, dictionaries, and booleans, and it encourages you to choose the right tool for the job. The choice matters because it reduces ambiguity. If you represent a set of usernames as a list, you can loop through it directly without worrying about spaces or delimiters. If you represent system facts as a dictionary, you can reference values by name instead of by position. Beginners sometimes resist this because it feels like extra thinking, but it is actually less thinking over time because your code describes your intent more directly. A classic admin scenario is collecting information from different sources and then correlating it. You might have a list of services, a mapping of service names to ports, and a set of checks to run, and you need to join those ideas into a report. In a text-only mindset, that can become a confusing tangle of separators and parsing. In Python, you can treat these as structured objects, like a list of dictionaries, where each item holds the related fields together. That structure prevents the accidental field shifting problems that happen when text is split incorrectly. It also makes security-related logic safer, because you can validate types and content before acting. For example, instead of trusting that a value is a number because it looks like 1, you can treat it as a number and handle the error case cleanly if it is not. This reduces the chance that malformed input causes unexpected behavior. Data types also matter for correctness in subtle ways, especially when you compare values. In many environments, values arrive as text, even when they represent numbers or dates. If you compare two numbers as text, you can get results that look wrong because text comparison follows different rules than numeric comparison. Python's types help you be explicit about what a value means, but you need the habit of converting and validating rather than assuming. For beginner admins, a good mental model is to treat input as suspicious until proven otherwise, not because users are malicious, but because systems produce messy data. Logs include unexpected characters, configuration files include blank lines, and output formats vary. When you handle types carefully, you create scripts that survive those inconsistencies. That resilience is not over-engineering. It is the practical difference between a script that works in a lab and a script that works in production. Once you start writing Python more regularly, you will hear about style and readability standards, and one of the most influential is Python Enhancement Proposal 8, PEP8. The name can sound formal, but the goal is simple. Code should be written in a consistent style so humans can read it quickly and accurately. For admin scripts, the audience might be you in 3 months or a teammate during an outage, which is exactly when readability matters most. PEP8 covers things like indentation, naming conventions, line length, whitespace, and general layout. The important beginner takeaway is not to memorize every rule. It is to respect the idea that consistency reduces cognitive load. When your code follows familiar patterns, your brain spends less energy parsing it and more energy understanding what it does. That is a security win too, because misunderstandings in automation can lead to misconfigurations or incomplete fixes. PEP8 awareness also connects to trust and maintenance. When code looks consistent, reviewers can focus on logic rather than arguing about formatting. When code uses clear names, it becomes easier to spot mistakes, like a variable that was supposed to represent a count but is actually holding a string. For an admin, this matters because scripts often become shared artifacts, even informally, and the moment someone else relies on your script is the moment it becomes part of the operational system. If the script is clean and predictable, it will be used responsibly. If it is messy and clever, it will be used cautiously or misused. One reason Python is so popular in infrastructure environments is that the community has converged on readable norms, so even people new to a specific codebase can navigate it. Treating PEP8 as a support rail rather than a school rule makes it easier to adopt. Another practical concern for admins is how Python code interacts with the operating system without becoming brittle. Even without getting into specific commands or tools, you can think about the categories of things admin scripts do: read files, parse text, handle paths, interact with processes, and talk to network services. Python has standard libraries for many of these tasks, and the standard library tends to be stable, which is great for operations. The risk comes when you mix system-specific assumptions into the logic, such as assuming a directory layout or a particular format of output, without validating it. A mature Python admin script tends to have a clear boundary between gathering data and interpreting it, and it includes checks that confirm the data matches expectations. This is the same idea as checking return codes in shell scripts, except in Python you often catch exceptions or validate types instead. Either way, the goal is to avoid silent failures and to produce errors that explain what went wrong. Virtual environments also play a role in keeping admin scripts safe to run repeatedly. If you have multiple scripts on a machine, each with different dependency needs, it is easy to create a conflict where installing one library breaks another script unexpectedly. Venv reduces that risk by isolating dependencies, but it also creates an operational obligation. You need a consistent way to ensure the venv exists and contains what the script expects. In team environments, this often becomes a simple ritual where the project includes a dependency list and the environment is recreated when needed. Even on a single machine, the idea is the same. You want to be able to rebuild the environment rather than nursing it. From a security angle, this supports patching and updates as well, because you can upgrade libraries intentionally and test the script, rather than leaving a fragile pile of packages installed system-wide because you were afraid to touch it. There is also a subtle learning benefit to these practices. They encourage you to think in terms of inputs, outputs, and contracts. A script takes inputs, performs logic, and produces outputs, and the environment is part of the input contract. When you specify dependencies, you are stating what capabilities your code expects. When you choose data types carefully, you are stating what shape your data has. When you follow PEP8, you are stating how the code should look so it can be understood. These are all small commitments that add up to reliability. Beginners sometimes think reliability comes from clever error handling after the fact, but the bigger source of reliability is preventing ambiguity before it turns into bugs. Python pushes you toward that preventive mindset, and once you adopt it, you will notice that even your shell scripts become cleaner because you start treating automation as a system with rules. To wrap this up, the core idea is that Python becomes an admin superpower when you treat it as a disciplined way to express intent, not just a different syntax for doing the same old tricks. Virtual environment, venv, habits protect the system and keep your projects reproducible. Dependency habits make your scripts predictable across machines. Modules help you organize and reuse logic without copy and paste, and data types let you represent information safely instead of constantly fighting text parsing. Python Enhancement Proposal 8, PEP8. Awareness is the final layer that keeps your code readable under pressure, which is exactly when admin scripts matter most. When these pieces work together, your scripts stop being fragile experiments and start becoming dependable tools you can trust during routine maintenance and real incidents. That is the level of confidence you want for Linux Plus, because it means you are not just writing code that runs, you are writing code that behaves consistently and can be understood when it needs to be.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.